Hello friends, good morning and welcome to our channel of Genius Structures. I'm your host Dr. Suman Kulkarni and we are here to study one more continuous beam by Slope Deflection Method. So here is our problem, a 3-span continuous beam, and this is the loading on the beam. If you can see, CD span is an overhanging span, so this beam has to be a part of a balcony. This balcony can be provided to a room or a hall. Okay, so if it is a 3-meter room, so it has to be attached to a bedroom. So practically this is the beam, continuous beam, which we can see. This may be a hall, this may be a bedroom, and this is a balcony, overhanging balcony. Okay, and this beam is the part of that balcony. Okay, so there are different loadings on the different spans. First of all, AB span 10 kilonewton per meter loading, UDL 4-meter span. BC span eccentric point load of 30 kilonewton, and balcony, the beam is subjected to 10 kilonewton per meter. So this is usually the flooring, load of the flooring. Okay, so let us start with the analysis of this continuous beam. So what will be our first step? It will be finding out unknown displacement quantities in the beam. So how to find? We have already seen this in all the previous questions, so I am not going to repeat it. Okay, so our first step will be unknowns, that is kinematic indeterminacy, because this is slope deflection method. So as per the procedure, kinematic indeterminacy for this particular beam is 2. Okay, number of displacement quantities. And which are those 2 displacement quantities in the beam? One is rotation of joint B, another is rotation of joint C. Okay, so these are our unknowns that we have first of all defined. Now we have to find out fixed end moments because of external loading. Okay, so these fixed end moments, we have standard formulae for this. So let us use those formulae and find out what are fixed end moments in each span. So first span is AB. So we will have 2 fixed end moments, MFAB minus WL square by 12. This is for UDL. So minus 10 into 4 square upon 12. So answer for this is minus 13.33 kilonewton meter. Okay. So MFBA, it is plus WL square by 12. So it is plus 10 into 4 square upon 12. So the answer is plus 13.33 kilonewton meter. Okay. Then MFBC. What is MFBC? It is subjected to eccentric point load. So minus WAB square upon L square. Okay. So minus 30 into 1 into 2 square upon 3 square. So this is again minus 13.33 kilonewton meter. Next is MFCB. So it is, equation is WA square B upon L square with plus sign. So plus 30 into 1 square into 2 divided by 3 square. So it will be 60 divided by 9. So the answer is 6.67 kilonewton meter. Okay. Then carefully see now, there is no fixed end moment for final span. Final span is an overhanging span, it is not intermediate span. Okay, so for overhanging span, MCD will be there, which will be final moment and not the fixed end moment. Please remember. So MCD minus 10 into 2 square by 2. Why minus? Because it is clockwise on right hand side of the section. I have drawn a section here, and the moment because of this UDL about this section on right hand side is clockwise, and as per the sign conventions clockwise moments on right hand side of the section will be treated negative. So the answer is minus 20 kilonewton meter. Okay, so we have our step number 2. Now we will go to step number 3. What will be step number 3? Slope deflection equations. So let us see one by one. Okay, so slope deflection equations. So we have seen what are slope deflection equations in the first video for this particular chapter. The derivation we have seen. So this MAB moment for first span, it is given by this formula 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L outside the bracket minus MFAB. So substitute the values one by one. So for span AB, distance is 4 meter, L is 4 meter, so 2EI by 4 into bracket. Theta A is 0 because end A is fixed. There is no rotation of joint A, so it is 0. Then theta B, it is unknown, that we have to find. MFAB we have got in step number 2, minus 13.33. So answer is 2 by 4, or the simplification of this equation is 2 by 4 is 0.5 EI theta B minus 13.33. Then MBA, again write the equation for MBA, 2EI by L into bracket, interchange of coefficients of theta A and theta B. So theta A plus 2 theta B minus 3 delta by L plus MFBA. Please note the change in the equation. So 2EI by 4 into bracket, theta A 0 and middle term is 2 theta B. There is no sinking, so delta is 0 and MFBA, it is plus 13.33. So the answer is 2 into 2, 4. 4 by 4 is 1. So EI theta B, okay, EI theta B plus 13.33. Then go to next span, BC. So MBC is 2EI by L into bracket 2 theta B plus theta C minus 3 delta by L minus MFBC. So 2EI upon 3 meter is the span of BC. So 2EI by 3 into bracket 2 theta B plus theta C delta 0 minus MFBC is again 13.33. Okay, so simplify this. 2 into 2, 4. 4 by 3 is 1.33. So this is 1.33 EI theta B. Next 2 by 3 is 0.67. So 0.67 EI theta C. And last term is minus 13.33. Okay. Next equation, MCB. So MCB is 2EI by L. Again the equation into bracket theta B plus 2 theta C minus 3 delta by L and outside the bracket plus MFCB. Okay. So again substitute appropriate value. So 2EI by 3 into bracket theta B plus 2 theta C. What is MFCB? Please see, 6.67 plus 6.67. So simplify this. It will be 2 by 3. It means 0.67. So 0.67 EI theta B. Then 2 into 2, 4. 4 by 3 is 1.33. So 1.33 EI theta C. Okay. And last term is plus 6.67. Now third span we have final moment in step number 2 itself. MCD minus 20. Okay, MDC has to be 0. So now we have to find these two unknowns. So we need two conditions of equilibrium, and for that we will form two equilibrium equations. So our next step will be equilibrium equations. So let us form these two equations from compatibility conditions. Okay. So let us take our next step, number 4, which is equilibrium equations. So these two equilibrium equations will be on two locations where there are two unknowns. So one unknown is on joint B. So at joint B, what we have? Equilibrium equation MBA plus MBC, it is equal to 0. So what is MBA? EI theta B plus 13.33. What is MBC? See here, 1.33 EI theta B plus 0.67 EI theta C minus 13.33. So take the addition of these two equations and write the final equations. So EI theta B and 1.33 EI theta B. So this becomes 2.33 EI theta B. Okay, 2.33 EI theta B. Then 0.67 EI theta C. Okay. And next term 13.33 plus, and here is minus. So this gets cancelled. So it is 0. This equation is formed. From one condition we have formed one equation. Another condition will be at joint C. What will be that? Similar to this, MCB plus MCD, it is equal to 0. Now what is MCB? Here 0.67 EI theta B. Okay. Next term is 1.33 EI theta C and plus 6.67 minus 20. So plus 6.67 minus 20 is minus 13.33. We will bring it on right hand side. It will become plus 13.33. So this is equation 2. So we have to solve these two simultaneous equations. Okay. So let us solve it. So our first coefficient 2.33, second 0.67, third is 0, then 0.67, then 1.33, and then 13.33. So from this what we get is EI theta B is minus 3.37. EI theta B is equal to minus 3.37, and next is EI theta C 11.72. So we have got the two unknowns. Theta B is minus 3.37 upon EI and theta C is 11.72 upon EI. So we have got the two unknowns. Now we have to substitute these two values in these slope deflection equations. So we will get final moments. So I just substitute these values here. Okay. So step number 5 will be final moments. So let us calculate now these final moments. So now I'll just calculate these values and I will note them in the loading diagram. Okay, instead of writing them here. So MAB is 0.5 EI theta B. So EI theta B is minus 3.37. So minus 0.5 into 3.37 minus 13.33. So the answer is minus 15.01. So that is anti-clockwise. Minus means anti-clockwise. So minus 15.01 kilonewton meter. Then next two values will be equal and opposite, MBA and MBC. So EI theta B, which is minus 3.37 plus 13.33. So that is 9.96. Okay, 9.96. Then MCB and MCD, they will also be equal and opposite. Now MCD we already know it is minus 20. So MCB has to be plus 20. That's it. Okay, so we have got all the bending moment values. So now we have got the final moments. However, we have to plot shear force diagram. There will be some points of zero shear force also, and we know on locations of zero shear force there will be maximum bending moments. So those also we will have to calculate separately. So after finding moments, we will now find reactions. So our next step will be finding out reactions. Okay. So how to get reactions? Take free body diagram for each part and show final moments, external loading, and then apply conditions of equilibrium. So joint B is internal joint, so I am going to assume fixed one. Okay. So this is 10 kilonewton per meter external load. Then this anti-clockwise moment of 15.01. Here is clockwise moment of 9.96. Then these are the reactions RA and RB1. And how much is span AB? 4 meter. Okay, so we know this much. Now here we will apply condition of equilibrium. Summation of moment about A is equal to 0. So minus RB1 into 4 plus 9.96 plus 10 into 4 square by 2 minus 15.01. This is equal to 0. So now we will solve this equation and we will get reaction RB1. So let us calculate this now. So this is 9.96 plus 10 into 4 square by 2 minus 15.01 divided by 4. So it is 18.74 kilonewton. RB1 is 18.74 kilonewton. Now to the same free body diagram, apply summation of Fy is equal to 0 condition. Okay, summation of Fy is equal to 0. So Ra plus 18.74, it is equal to 10 into 4. So subtract this 18.74 from 40, we will get Ra. So 40 minus 18.74. So how much is that? 21.26. 21.26 kilonewton. Now come to second span, span BC. So span BC is having only single point load. So that is how much? 30 kilonewton here. What is the moment on joint B for span BC? 9.96 anti-clockwise. Okay, so show it here. For joint C, it is 20 kilonewton meter clockwise, and show these two reactions. So here we will say this reaction will be as RB2 and here RC1. This is 1 meter and this is 2 meter. Okay, so again we will apply these two conditions one by one for this free body diagram. So summation of moment about joint B, it is equal to 0. So minus RC1 into 3 plus 20 plus 30 into 1 minus 9.96, it is equal to 0. So find out RC1 from this. How much is RC1? Carefully see now. 20 plus 30 minus 9.96, and this is totally divided by 3. So answer is 13.35. 13.35 kilonewton. Now second condition, summation Fy is equal to 0. So here Rb2 plus Rc1 is 13.35. It is equal to 30. So subtract 13.35 from 30. Okay, 30 minus 13.35. So it will be 16.65. 16.65 kilonewton. So what will be net Rb? Net Rb is Rb1 plus Rb2. So how much is Rb1? 18.74 plus Rb2 is 16.65. So find out this. So it is 35.39. Okay, 35.39 kilonewton. So two reactions we have found, Ra, Rb. Now we have to find Rc. So go to third free body diagram. There show this loading 10 kilonewton per meter. And how much is the moment here? Minus 20 anti-clockwise. Okay. So how much is this distance? 2 meters. So here only one condition is sufficient to find out Rc2, because there is only one unknown. Here there used to be two unknowns. So we have applied two conditions. Here there is only one unknown. So one condition of equilibrium, which one is appropriate? Summation of vertical forces. So Rc2 is 10 into 2, 20 kilonewton. So net Rc is Rc1 plus Rc2. What is Rc1? 13.35. Okay, Rc2 is 20. So how much is this? 33.35. Okay, 33.35. All the reactions are upward, because as per the calculation our answers are positive. It means our assumed directions are correct. Now we will show these reactions first. So Ra is 21.26. It is here. Next Rb. So Rb is here. How much is Rb? 35.39. And next is Rc. How much is that? I just rub this now. So Rc is 33.35. Okay, 33.35 kilonewton. Now we are going to plot the shear force diagram. So let us do it now. I will rub now these all calculations. These are not required. So let us take first of all the projections just for the reference, and then we shall plot SFD. Then we will locate points of zero shear force from SFD, and there we will again find what are the corresponding bending moment values. Then we will draw BMD, then it will be O1. So finding out unknowns in this problem, finding out moments is difficult. Easy. SFD BMD, lengthy procedure and time consuming. Okay, so make a good practice of these questions. Okay, so this is our reference line for SFD. So 21.26. So it is here. 21.26 kilonewton. From this, now subtract 10 into 4. 21.26 minus 40. So how much is the answer? 18.74 with minus sign. So minus 18.74. Okay. In minus 18.74, add 35.39. So how much will be that? 16.65 with plus sign. 16.65. Then it will be same up to this point load. From this 16.65 subtract 30, so we will get 13.35 with minus sign. 13.35. Okay. Extend it up to joint C. Now in minus 13.35 add 33.35. So it will be plus 20. So here is 20 kilonewton and it will be 0 here. So this is our shear force diagram. This is plus, minus, plus, minus, plus. Okay. So where is our points of zero shear force? One is here. So here we need to find additionally the bending moment. Here and here we already know. Okay, so we will just assume this as distance x. So how much is this? 4 minus x. And we will make use of these two triangles, and from similarity of triangles we will find out x distance first. So when x is the ordinate, x is the distance from this origin, how much is the ordinate? 21.26. And from the same origin, when 4 minus x is the distance, how much is value? 18.74. Is neglect plus and minus. So 18.74x, it is equal to 21.26 into 4, which is 85.04 minus 21.26x. So x will be how much? 85.04 divided by 18.74 plus 21.26. So answer is 2.13. 2.13 meters. So we will take bending moment at a section x is equal to 2.13 meter from support A, and we will write now equation of moment. So bending moment at x is equal to 1.23 meter. Write first of all the equation. So 21.26 into it is 2.13 actually. So 2.13 minus 15.01 minus 10 into 4 square, 2.13 square by 2. Let us calculate this value. 21.26 into 2.13 minus 15.01 minus 10 into 2.13 square. So how much is the answer? 7.59 plus value. It has to be plus because shear force is changing the sign. So 7.59 kilonewton. Now another value will be here under 30 kilonewton point load. We shall say this is E. So bending moment at E. So we know what is the location of E from any of the joints or supports. So we will take this complete part of the beam and we will write down equation for bending moment starting from 10 kilonewton per meter. So 10 into 2 into half of 2 is 1. 1 plus 2 is 3. So moment because of 10 kilonewton per meter. So that is clockwise moment. Please remember. So that will be minus. Then 33.35. So that will be plus because anti-clockwise on right hand side of the section. So plus 33.35 into 2. Okay. And that's it. Only two things are there. So 33.35 into 2 minus 10 into 6. So answer is 6.7 kilonewton meter. So please see, on this location we have moment value. Here we have got 7.59. Here we have 9.96. Here we have got just now 6.7. Here we have 20. Here is 0. So now we will plot the bending moment diagram. Okay. So now let us see what are different values. 15.01 anti-clockwise, so minus, we will plot it below the reference line, 15.01. Yes. Here we have a plus value of 7.59. So here next is here value is 9.96. Then under 30 we have 6.7 plus value, so 6.7. Then on joint C we have 20. And here it is 0. Now how to join? Wherever UDL is there, follow parabolic variation. So from A to B, everything will be parabolic. Something like this. Then point load, linear variation. Okay. Here for balcony area, cantilever part of 2 meter, we have again parabolic variation. Why? Loading is UDL. So this is minus, this is plus, minus, plus, and this is minus. So this is our BMD on tension side, and the diagram in the black, it is our shear force diagram. So friends, this is my analysis of this particular continuous beam by slope deflection method. So I hope there has not been any difficulty for you to understand the concepts. If at all you have any questions, do write in the comment. And if you are new to the channel, please subscribe the channel and hit the bell icon. Thank you very much.